Many archaeologists have suffered the issue of not being able to analyze their findings because it was too damaged to inspect. However, with the discovery of a new method called X-ray phase contrast, we are now able to virtually unfold these documents.
But before we get to that, we need to understand what is X-ray phase contrast and how does it work.
So, phase contrast X-ray imaging is a term for different technical methods that makes use of the refraction of X-rays by the sample in image formation to generate the image.
The beam's phase shift caused by the sample is not measured directly, but is transformed into variations in intensity, which can then be recorded by the detector. This technique is especially useful when applied to samples that consist of atoms with a low atomic number, such as natural materials like wood and paper. Because X-ray phase contrast is more sensitive to density variations in sample than conventional X-ray imaging. This leads to images with improved soft tissue contrast.
There are multiple techniques of getting images, for example, crystal interferometry, analyzer-based imaging, propagation-based imaging, grating-based imaging, and so on. But for simplicity's sake, we won't get into those details. It's pretty hard to understand and the video would be too long. So, how is it used in archaeology? An example we have chosen is analyzing ancient manuscripts that are too fragile to physically unroll. The way it works is that each material in these artifacts is absorbed by X-ray radiation differently. The scroll absorbs the radiation minimally, but the ink absorbs the radiation significantly more than the material the scroll is written on. This creates the sharp contrast we see between the texts and the scroll in the final images of the virtually unwrapped scroll.
For example, here we have the Ein Gedi scroll, a burnt ancient Hebrew parchment found in 1970, a 2nd or 3rd century manuscript. The technology in order to read the scroll was not available until 2016. It was damaged by the fire, and trying to unroll it physically would only cause it to crumble.
Undertaking to digitally unroll it, it was taken through a virtual unwrapping process to scan the damaged scroll. This scan is non-invasive and uses the same technology as a traditional CT scan. When the scroll completed a full rotation with respect to the X-ray source, the computer generated a 2D slice of the cross-section, and performing this multiple times allowed the computer to build up a 3D volumetric scan. So, thanks to the use of X-ray phase contrast tomography, many documents formerly thought to have been lost to time are being digitally unrolled and are giving us valuable information of the past. So, as we can see, nuclear energy has a wide variety of usage, finding its way even in archaeology, helping us read ancient manuscripts.